Hi. Hi. Yeah, sorry. I just wanted to make sure you're gonna see my T-shirt for the FOSDEM conference next year, because AsyncAPI will be there. But yeah, let's get serious for a second, at least in my life. So I'm Lukasz Gornicki. I can come up with many different labels to describe myself. Like one of my favorites is that I'm open source fanatic, but I'm also independent maintainer in open source, a technical steering committee member, and a executive director at AsyncAPI initiative. But for the sake of this conference, I put a different label on myself. It's a label of a researcher. So I, over last months, like started already last year, no, actually, it's more than last year. Okay, let's be honest. At least a year of research, if not a year and a half. Well, yeah, time in life of a 40-old person flies. But yeah, let's go back on the track. So the research I did was based on a publicly available information that I wanted to basically go through, discover, and see how people use AsyncAPI in production. So whatever you're gonna see today during this presentation, it's all based on publicly available data. So some presentations, documentation, slides, nothing that was privately shared, nothing that I would get from some other sources and you're not able to double check what I'm saying. So remember that there are much more companies using AsyncAPI. The thing is that event-driven architectures, they're pretty much internal solutions, and companies don't like to share that much about how they do internal. But yeah, luckily there are enough heroes in the open source that talk about it. And yeah, let's see what we have. So I think the best way to start the presentation is to start a presentation with some complaints. So yeah, this is a screenshot showing AsyncAPI landing page. You can see here a typical visual approach of explaining in short what AsyncAPI is and what it can be used for. Visually nice, docs generation in the best way of showing benefits of AsyncAPI pretty quickly, right? YAML on the left, docs generated on the right. But the thing is that, to simplify the explanation, we also kinda do a pretty large disinformation here. Because using AsyncAPI just for docs is a very bad investment. Also, good luck to any developer who will convince their teammates to learn AsyncAPI just to generate documentation, because we all know what's the common approach of devs to docs. So documentation generation should be considered an extra result, not your direct investment. It's a extra result of your main investment. It's like a side effect, like an extra Christmas bonus. So good news, there's a bounty issue. So we have a work in progress to redesign the landing page finally. So no more complaints from my side. Our extra designer, Maya, she's working on making it better and make sure that on the landing page we already make it clear what AsyncAPI can be used for. But yeah, I'm telling it to you just to get you involved. So if you have opinions already, or you disagree and you think what we have now is perfect, then yeah, join the discussion. So I'm around AsyncAPI for 6 years now. I remember countless questions from different people about what they can do with AsyncAPI except docs. And I was just saying hey, it's a machine readable format, right? So yeah, the sky is the limit. Just take it and do whatever you want with it. which makes sense, of course, technically accurate. But yeah, over time I understood things really might not be so obvious for everyone. It all depends on our context, where we're coming from, our experience. Even the concepts of code generation, people understand it in different ways. So it is like this, especially that we're, as humans, like we like when somebody gives us an argument based on some like real story. So it's really not enough that somebody will tell you like, hey, you can do code generation. Because we prefer to hear a sentence like, hey, you can do code generation, like, for example, company X is doing. And here we go. You can like check what I'm saying. That's a link to the conference talk where they were describing how they use AsyncAPI for code generation. And it's basically that instead of trusting and believing, like we really prefer to have a like a backdoor, like an option to double check what the person is saying to us. The research that I'm doing is for quite long now. It's still work in progress. So the list of things that I'm gonna present today, I already know that in 2 months it's going to be outdated, because I already know, for example, that at AsyncAPI conference in Paris, December this year, there will be another completely new use case presented. So especially if you're one of these great companies that want to publicly tell us so we can learn from you how you use AsyncAPI, then remember, like, it's not the last moment when you can show up on this presentation. Let us know, share your story so we can include it, because later on, whatever I share in this presentation will end up in our official website. At least I hope so. So remember, things you can verify. The companies that I'm going to mention today, all the use cases, most of it is already published on asyncapi.com. We have a nice table that will be a bit reorganized to have it grouped in the way as I'm proposing today in my presentation. But yeah, you can already share whatever we have there with others through that pretty simple link. So yeah, when we talk about using AsyncAPI in production, let's first see what companies do use it, and like in what industries their use cases are applied. You'll notice a pretty obvious pattern that will show these industries in my presentations that you recall also from whatever guides you have about event-driven architectures. So whenever you start with event-driven architectures, you want to see what are the use cases, what industries they're used in. That's also what you're gonna see now in case of AsyncAPI. So first, insurance and finance space. So basically any financial institution that wants to do digital banking services need to rely on event-driven architectures. As at the moment, it's the only way for scaling digital solutions, like infinitely, basically. And in this list, you'll see like all the different possible players in this digital banking. So you have financial institutions, you have traditional banks, you have fintech startups, and insurance companies. Now, in case of retail and e-commerce, you can probably already notice some well-known companies that use AsyncAPI. It's Lego, it's Adidas. But also there are big companies that have like a network of shopping centers for different purposes. You have Walmart, you have Adeo, and that all is especially related to retail, apparels, basically digital selling, e-commerce. That's a typical industry. That's a typical place where people apply microservices architecture. And in case of microservices, if you want to scale them a lot, you cannot have microservices connect to each other directly. You need to have an event bus in between, you have to use event-driven architecture. And because you're using event-driven architecture, you also need AsyncAPI. I don't think it's strange to have on the slides also a category called software vendors. So in case of software vendors, it's not only, we don't only have companies that sponsor AsyncAPI and they basically enable some features around AsyncAPI. There are also companies that build some different software, not even API related, but even if they build some API related stuff, it might not be AsyncAPI related. It's just some platform or whatever, and they need event-driven architectures as well to enable teams to be independent. So you can see, for example, here on the list, Postman that use AsyncAPI internally to enable teams like work more efficiently on Postman workspaces. But you also have, for example, Adobe, or for example, Oracle as well, that both of them use AsyncAPI for code generation for stuff not really related to AsyncAPI itself and AsyncAPI features. And last but not least, Internet of Things. So in this particular slide, you have a mix of different companies from like different entities even, that basically need for some use cases IoT. So you have Zara Robotics that is doing robots, basically that you can have at home. They have to communicate over event-driven IoT, AsyncAPI. Kuehne+Nagel, it's a company that is managing ports, shipping ports, of course, not like sockets. And but you also have academics on the list. So far, so good. Obvious information, nothing extraordinary. So again, as I said, wherever you apply event-driven architecture, the same industries need it. The same industries will need AsyncAPI. Now, let's try to look at the same topic of AsyncAPI in production, but from the protocol perspective. Let's see what protocols are really used with AsyncAPI. So AsyncAPI sets a standard approach for describing things in event-driven. No matter of what protocol you use, you can use AsyncAPI. But of course, sometimes you want to provide some specific information about some protocol. That's why we have a feature called bindings for protocol-specific information. So yeah, let's see, like, do people need it? And are people really using AsyncAPI for any protocol out there, or it's just Kafka? So this one, again, sorry for using word obvious, but I think especially for people that use do Internet of Things, like MQTT is a de facto standard protocol. So it's not a surprise that if in previous slides you could see IoT, then yeah, MQTT will be the answer. So whenever you think you need to connect hundreds of devices to your system, you need IoT, you need MQTT, and eventually you're gonna need AsyncAPI. WebSocket. So in my years, WebSocket was like usually for front-end real-time message exchange, but the adoption increases recently a lot, especially in finance, but not only. So for example, you see on the list here also Oracle, that in their case is also like a great example of how WebSockets help in event streaming concept. So basically in case of Oracle, they expose the API where they provide a stream of events that inform anyone who's interested about the changes in the databases. So WebSocket, AsyncAPI, they match together perfectly. HTTP, in case of here we have eBay, and they are using AsyncAPI for exposing the notification API. Apache Kafka, you see bigger list of companies. So yeah, at least in my bubble, seems that Apache Kafka is the most popular solution for event-driven architecture. Like variety of different companies use it. Doesn't matter really if it's banking, as you can see on the list, or it's e-commerce, or even IoT. where it's a pretty common as well that devices send events using MQTT, but they send it to basically a Kafka broker that later on enables developers to plug into the system and listen to the changes in the within the devices. The next one, AsyncAPI. It's another protocol that is used in AsyncAPI. In this case, it's insurance company, and it's also, in their case, actually related to the infrastructure that they're using. As in case of this particular case, it's a Azure bus service. But it's not only that AsyncAPI and Azure has something common. You have also SNS and SQS, for example, that is very tightly connected to AWS, and companies that usually use SNS and SQS and use AWS, they just use it because it's a common solution for any other cloud services that they need in their company. So you have like looking at the list, I think the most interesting is to see the Lego, which not as the name of the company, but you're gonna see Lego also on another slide for Apache Pulsar. So you also see something that we talked about many times in our community, but we never had a confirmation, of course, from like production, because sometimes people were questioning, would I really use AsyncAPI document for two different protocols? And yes, you would, like, and also in the company, you would use different protocols for different solutions. Like in Lego, for some cases, they use SNS SQS. For some, they have Apache Pulsar. So yeah, event driven, it's a complex beast. But I think it's also pretty normal that like you want to use different protocols for different use cases because they're designed for different use cases. And like basically you ain't gonna use a hammer to cut some wood with precision. Okay, so basically an event driven related protocol, any event driven protocol that is out there, it can be used with AsyncAPI, and yeah, we can see it already is. So yeah, use cases, I think that's the most interesting thing, right? Okay, whatever companies use it, whatever protocols it's used for, but what actually it's used for. Let's do some quick breakdown. So we have infrastructure as code, or a like name that I heard like pretty recently, thanks to the AsyncAPI conference we had in London. So there's a term coined by folks from FinOS Foundation related to fintech, and yeah, they coined a term called architecture as code. So yeah, you tell me later which fits better to describe what I'm gonna talk about this use case. Now also we have self-service use cases, solutions, basically whatever you can do to not use Jira tickets. Governance and consistency, the quality of service monitoring, the cost control, which is very much related to infrastructure as code, but I think it really deserves a separate explanation, especially because of the financial aspect of it. Now, of course, we have on the list code generation, and last but not least, a developer portal. And notice I'm not mentioning anywhere that one of the use cases is to generate documentation page for your service. So infra as code. That's my favorite, like mind blowing for myself, how like useful AsyncAPI can be. So it's basically like treating AsyncAPI as an infrastructure configuration file. It's like really neat because like if you treat AsyncAPI as a config and you use it to configure your infrastructure, then you have to put a bit more love into the accuracy of information you put inside the AsyncAPI document. You have to keep it up to date, because if you don't keep it up to date, then yeah, forget that your infrastructure will work with your deployed service. So basically AsyncAPI becomes a source of truth. And then imagine if you're an architect and you have like hundreds of AsyncAPI documents that are up to date, then you can probably think about some new use case, like trying to read out the information from all AsyncAPI documents and generate some beautiful UML diagram to see how the infrastructure looks like. But yeah, let's forget about dreaming and let's go back to the earth. So in the picture, you can see, let's say, a screenshot from the presentation from Kuehne+Nagel. I choose this one because I'm always probably gonna be a fan of Kubernetes and Argo CI/CD and like all this concept of operators. But yeah, doesn't matter what I'm fan of. Let's quickly go through what is, like, in case of, for example, Kuehne+Nagel, what this infrastructure as code means. So yeah, what you basically can see that, yeah, AsyncAPI is a configuration file. Then what happens, then some team puts it in repo, then there's of course some listener, then CI starts whenever there's some change or a new AsyncAPI document. And what happens is that the Helm chart gets generated out of the AsyncAPI document, and then it's applied to the Kubernetes cluster. As a result, what happens is a custom resource definition is created, and in case of Kuehne+Nagel, this custom resource definition is interpreted by Stringy, which is an open source Kafka operator. So you can imagine, like, the CRD contains the information about what a given team needs on Kafka, like what topics, etc. And the Stringy operator, basing on this information taken directly from AsyncAPI, can set up everything in Kafka in automated way. Of course, then it means that before this happens, before the CRD is applied, you can do a lot of checks, double checks, like verifications, etc. before you set up some things in infrastructure. And it's just story from one company, like how Postman does it internally. That's super interesting. Not to mention Lego. So yeah, it's just one use case. Let's go further. So self-service, or as I like to call it, like burn this damn Jira tickets. So yeah, let it sink in. So just looking at the Bank of New Zealand example, that's a slide from the presentation from Bank of New Zealand that presented it at Kafka Summit. So yeah, basically, don't stop on only managing your infrastructure with AsyncAPI. So you can, if you build a self-service for your teams, doesn't matter if it's Kafka, Argo CD, or some other solution, like we use it to improve the developer experience. So even if it's only for internal teams, like in case of Bank of New Zealand, so give them tools to automatically lint documents, generate docs, and publish to developer portal, and do even more. Like in case of Bank of New Zealand, when the self-service accepts the AsyncAPI document, of course puts docs somewhere else, but then it also extracts the Avro schemas and uploads them to Confluent Schema Registry, which later on can be used nicely in runtime for messages validation. So like self-servicing the work for devs, they love you. Like if you provide them with tools where they don't have to interact with you, even if it's not direct interaction with human, but through Jira tickets, do it. Because then later on you can plug in a lot of good stuff in the process. And this takes us to one of the steps you can do in self-service, which is governance and consistency, which basically means, at least from my side, like freedom is cool. You can scale faster when you have freedom, but at some point of time, even though your teams like independence, you have to do some regulations. So you basically need to establish some standards to, I don't know, like simple things. Make it easier for different departments, different companies to communicate, to have some common vocabulary, to follow the same even naming of topics. It makes things easier, lowers costs, etc., etc. So all of this is possible only if you first make sure that your information is accurate and consistent. This requires a proper governance setup and governance automation. And this automation, in case of event-driven architecture, is possible only if you use AsyncAPI. Because if you have AsyncAPI machine-readable format, then you can apply to structures, AsyncAPI structures, whatever validations you want, whatever governance you want. And as you can see, for example, in this screenshot, pretty important to notice, that's from the Lego presentation. Sometimes just like, you don't have to start super big, like you can really start small. You can just enable some basic linter, like in here, it's with Spectral, with some basic rules. Sometimes it doesn't even have to be really automated. It doesn't have to be self-service from day one. It can be just a, a CLI tool that any team can download and use and plug in into their CI on their own. Next one, quality of service monitoring. It's a use case from University of Catalonia, and it's based on their work for Port of Valencia in Spain. And it really nice shows the benefits of extending AsyncAPI, like adding extensions. So what they did is that they basically established a quality of service and service level agreement standard description, and they could use it to describe the SLAs that are required for given type of devices in the port. And devices, this devices controlling port are connected with each other and other system over Wi-Fi connection, and they require really high quality. But you can imagine that, in ports, when you have hundreds of thousands of containers and many of them are in motion, then the quality of Wi-Fi connectivity can be affected, delay things, and delays mean money, because there's a lot of money in transportation, especially if it comes to containers and ports. So you want to
Hello, everyone. I hope all of the people who are listening to this session are doing well.
Hi. I mean, to be self-service from day one. It can be just a CLI tool that any team can download and use and plug in into their CI on their own. Next one, quality of service monitoring. It's a use case from University of Catalonia, and it's based on their work for Port of Valencia in Spain. And it really nice shows the benefits of extending AsyncAPI, like adding extensions. So what they did is that they basically established a quality of service and service level agreement standard description, and they could use it to describe the SLAs that are required for given type of devices in the port. And devices, this devices controlling port are connected with each other and other system over Wi-Fi connection, and they require really high quality. But you can imagine that, in ports, when you have hundreds of thousands of containers and many of them are in motion, then the quality of Wi-Fi connectivity can be affected, delay things, and delays mean money, because there's a lot of money in transportation, especially if it comes to containers and ports. So you want to optimize it. You want to not only optimize by fixing fixing the I don't know, having better rotors, having better antennas or whatever, you need to have a proper monitoring in place. You have to have someone in some room getting alerts that, hey, like we have these devices here and there, and they're getting the quality that is not is below the expected SLA. So we need to react because we're losing money. So yeah, that's basically possible by extensions in AsyncAPI. You can have a set of devices described with a certain SLAs, what are the requirements, and later on you can of course interpret this information in the alerting system that you build. The cost control, as I said, it's pretty cool. That's why it's separate. Might be known and obvious for people using Apache Kafka and Pulsar. So these brokers have a pretty nice feature called dynamic topics creation. It's great for dev teams, like again, teams like independents, so they can quickly get the topic created in Kafka and start sending events to some other teams that requested it. So it's definitely not so great for infrastructure team, you can imagine, a credit card owners. Because in short, like in Apache Kafka and Pulsar, things work in the way that the more topics you have, the more clusters you need. So if teams can dynamically create Kafka topics and teams are not responsible for costs, then they can really reach the credit card limits pretty fast. So AsyncAPI helps making both groups happy. So you can basically disable dynamic topic creation. That's what happened at Lego. But at the same time, the infrastructure team, what they did, they enabled the API that any team can upload their AsyncAPI documents to. And as a result, what happens, like they basically go to the teams and they tell them like, hey, send us your AsyncAPI document if you need the topic really quickly. We'll set up for you some access rights. In their case, it's Azure access management, and then you can. We're gonna create a topic for you, and we're gonna return all the information you need to connect to the topic. So it's all automated. It's perfect for you. And as a bonus, like a nice really side effect of the approach, we're gonna take your AsyncAPI document and we're at the same time also gonna push it to developer portal, so anyone can immediately have access to documentation. You're welcome. And I think it's pretty cool. Like it's like making developers happy, credit card owners happy, and taking feature away from developers, but in exchange giving them much better feature, which also works on demand dynamically. Code generation. It ain't that simple. It's not that obvious. So there are like many different concepts in code generation related to many different types of generation. Like basically, just look on the screenshot that I'm showing here. It's a screenshot from AsyncAPI Modelina Playground that shows a pretty simple models generation. So you can basically, out of AsyncAPI document that keeps the schemas, you can generate models, classes for whatever programming language you want. And for many companies, that's really enough. For example, it's guys at Adobe are super happy with it, and they were able to convince other folks at Adobe to use AsyncAPI, just because they don't only get docs but also models generation. But code generation is more. Like it can be mocks, for example, generation for tests, or examples generation, or client generation, like for example in case of Oracle that you can see here on the list, or it can be like apps scaffolding, like in case of Adidas, or like in case of University of Catalonia, they even have their own open source toolkit integrated with Eclipse IDE, and they use it for many different things, like especially in their quality of service monitoring, and they generate all this alerting code out of the AsyncAPI documents. But there's something else that also showed up on my radar because of some conversations at AsyncAPI generator and this whole infrastructure as code topic. And it's basically generation of scripts that later on you can invoke on, for example, Kafka broker to set up some topics. So code generation, it's not just models. It's okay if it's just models, but yeah, I mean, look further. There are some more interesting things around code generation. Last but not least, developer portal. This is also pretty complex because, again, it really depends on your budget, on your needs. Like big players, as you can see here, as on the screenshot, in this case it's eBay, but also Walmart, what they do, they build their own developer portals. They have budget, they have huge teams, they can invest in it, which also in their case, it makes sense because API is part of their revenue. But I always say that custom developer portal should never come first. Like first, you need to make sure that your teams, like what your teams need, like gather information, understand how they perceive event-driven architecture. Maybe like Lego on the list. You can use Backstage, open source project that is under CNCF. And it enables you to like basically build developer portal with code, with docs generated from various standards like AsyncAPI, OpenAPI, or GraphQL. Pretty neat, and you don't have to build anything from scratch. Or if you kind of start with blank card, some new project, try to stop comparing OpenAPI and AsyncAPI, because if you like, if you're gonna try to reflect and like ease your understanding by comparing to OpenAPI, you're gonna apply the same things, the same ideas that you know from OpenAPI, and it's gonna be reflected in developer portal, like for example in Backstage usually happens, and you're gonna have basically a list of services documentation in your developers portal, and you will force your readers to think of event-driven architecture as a group of producers of events that you have to know. But the truth is that in event-driven architecture, that's the beauty of event-driven architecture, you don't have to know your producer. You're interested only about the message, and you want to consume the message, and you don't care who is producing that message. So consumers need information just from the system, and they only need to know where they can and have to connect to get the message and how to serialize the message. And that's it. And who produces it? That's extra fluff information, technically not important for them. And that's what, for example, TransferGo does here. So they use this open source project called Event Catalog, that is capable of reading AsyncAPI document and outputs not a list of services and their dedicated API docs, but it outputs a catalog of events. And you just browse and search through the messages that you need, and then you can check their schemas. And who produces the message? That's probably some small label in the details of the event documentation, because it's not really that much important. But yeah, basically a developer portal that is not producer centric but event centric, that's a really great concept to look at and be open for it. So yeah, even in event driven architecture, even though somebody says OpenAPI is for sync, AsyncAPI is for async, and they're the same, just use it the same way. Even in case of developer portals, you have to think twice, talk to your folks, see what they need. Okay, wow, that was a lot, and again, let me emphasize something that I already did a few times during this presentation. If you really want to use AsyncAPI just for docs, nobody's gonna block you to do it. But remember that event-driven architectures are complex. AsyncAPI, because of what it's for, is also complex. And it doesn't matter how much we try as maintainers of the spec to make it easier, it always will be a complex structure. So if at some point of time you decide to use it and use it for the docs, please try to stop for a second, and I know that from my own experience also when I was in a team. We were AsyncAPI users, but also because of open API experience, what we did in the team, we just first were using it for documentation and concept of event catalog for ourselves. There was no yet event catalog open source project, so we were building it in-house. This event catalog came to our heads way too late. There was no one that could educate and suggest us that use case. So please take a moment, listen to me. You can just verify what I was saying, of course. But yeah, listen for once, this old bald guy from Poland, and slow down. I know you have your sprints, I know you have your agile ceremonies, you have your release cycles, but try to think for a second beyond that next deadline and think about the other deadlines that will follow, and see how AsyncAPI can help you out reaching the deadlines faster and cheaper, because it's really worth investing more into it, and docs will come out of the box as a bonus. So yeah, thank you so much for listening. Remember, folks, AsyncAPI Initiative is not a company. It's an open source project hosted under Linux Foundation, and it's purely community driven. So if you I encourage you, if you want to join and continue discussions on any topics, or continue discussion about this particular topic, then join the community, Slack, whatever place you want, or just reach me out on LinkedIn. Yeah, it was a pleasure to talk to you, folks. Cheers.
Wow, such an amazing talk it was, Lukash. And I love the ending note that Async API is not just a company, it's an community driven open source project. So I think that pretty much sums up everything. We're open for questions, folks. If any questions you have, please feel free to drop them in the chat. Okay, we have one question. Uh, Does this mean code first approach where specs are results of code and docs are result of the specs better?
I wish I have a clear answer to this one, because it all depends on the tools you use. In theory, generating from code is much, much better, but then you really have to have a good tool, an accurate tool, that you can use to generate really good quality async API.